Okay, so this is a problem on, it says for each data set below, calculate the variance and standard deviation. Symbol for variance, it's called the sample variance, is S squared. The sample standard deviation is called S. Here's the formula, all right? The S squared means variance. This capital sigma means that you add things together. The X values are your data values. The mean, that's your average. So you're going to subtract them, then you're going to square them, then you're going to add them all together, and you're going to divide by n minus 1. N is the number of numbers, so like in this case, n would be 5. Okay? So I'm going to you don't have to do it on the worksheet that you have, but I'm going to show you a dot plot of this too. So if you have a 3, 2 5s, 7, and a 10, that's what the dot plot would look like, or the line plot, we might call it. Over here, you have 4, 12, 14, 17, 25, and 30. So just looking at those two graphs and looking at the numbers, which one do you think is going to have a higher variance and a higher standard deviation?
One on the right.
The one on the right, yep, plot B. Because the data is more spread out, okay? More spread out means a bigger variance, a bigger standard deviation. And what you're really looking at is how spread out the data is from the mean. So, you know, the mean, like, the mean in here is going to be somewhere between 3 and 10. You know, maybe somewhere around 6 or 7. So you can see, like, the data values aren't that far from 6 or 7. 10 is only 3 or 4 from 6 or 7. 3 is only 3 or 4 from 6 or 7. So the data values aren't very far from the mean. Here, the mean is going to be somewhere between 4 and 30. You know, maybe in here somewhere around 15 or 16. Okay? So here you've got values way out here. Like 25 is 10 units from 15. 30 is 15 units. The values are more spread out from wherever the mean is. Okay? So more spread out means a higher variance, higher standard deviation. Now to do these, what I'm going to suggest is you make a table. You list your X values, in this case 3, 5, 5, 7, and 10. Then you take X minus your mean. And to get the mean, you add all these together and divide by 5.
So are these little tables going to be on the test?
Yes. Yep. Yep. So to get the mean, you add these together. So if you add these together, that's 13, 20, that's 30. 30 divided by, so I'm going to add all these together. Add them together, I get 30. Divided by 5 numbers is 6. So here I'm going to take 3 minus 6, 5 minus 6, 5 minus 6, 7 minus 6, 10 minus 6. I'm always going to subtract from the mean. So that's going to give you negative 3, negative 1, negative 1, 1, negative 4. So really what you're doing is you're finding out how far each number is from the mean. That's what variance and standard deviation does. It kind of gives you a measurement of how far all the values are from the mean, kind of on average. Next, so we've got that figured out. Now I have to square them all. So I'll take X minus the mean and square all those. So negative 3 squared. Negative 3 times negative 3 is positive 9. Negative 1 times negative 1 is 1, 1, 1, and 4 times 4 is 16. So these numbers should always be positive, because when you're squaring numbers, you always get a positive. Add those together, that comes up to 28. Total's 28. So this total up here, when you subtract X minus the mean, you square them all. This means add them all together, you get 28. So now I have to divide by n minus 1. So my variance is going to be 28 divided by n minus 1. N is the number of numbers. 1, 2, 3, 4, 5. So you're going to do 5 minus 1. So 28 divided by 4 is 7. That's my variance. Standard deviation, which is S, is simply the square root of that. 2.6. 2.65 approximately. Now you might be saying, why do you need both? Why do you do the variance and standard deviation? Well, here's the deal. For example, let's say these were years. Maybe these were ages of kids in a school. So as you go through the process, this would be like a 3-year-old, 5-year-old, 5-year-old, 7-year-old, 10-year-old. These numbers would mean that like this person is 3 years younger than the mean. This person's 1 year younger than the mean. When you square it, the label on this would be years squared. And the same thing here when you add them together. The label here would be years squared. Well, that doesn't really make sense. You know, if someone says, how old are you? You don't say 10 years squared, do you? So This label would be years squared. When you square root it, that takes it back to the original label. So I think the reason that we take the square root is to get it back so that you have a label that kind of makes sense. The standard deviation is 2.65 years. The variance is 7 years squared, which we don't really usually label that because it really doesn't make sense, 10 years squared. Any questions about that? And then if you wanted to, I'm not going to go through all the process here, but here you'd list all the numbers. You'd find the mean by adding them together and dividing by 6. You take each of your data values minus the mean. You square each of those answers. You add all those together. If you add them all together, this is what you should get. I'm just going to give you some numbers so that you can kind of check your work. If you want to try this on your own, then you can at least see if you're on the right track. Then to get your variance, you take that total of 436 divided by 6 minus 1, which is 5.
It's 87.2.
Comes out to 87.2. So then the standard deviation would be the square root of that, which is approximately 9.3. And as you can see, this variance, 87.2, is bigger than this variance, 7. And this standard deviation, 9.3, is bigger than this standard deviation. And that's because the data is more spread out away from the mean. And it's plot 2.